For more problems and videos like this for linear algebra, you can take a look at Sarai Studies. Link is in the description box below.
Let W be the union of the first and third quadrants. So they're talking about a coordinate plane, and W is literally the first and third quadrant. So how do you know which quadrants? Remember C for coordinate plane, so this is the first, and then second, and then third, and then fourth. So W is the union of the first and the third quadrant. In other words, this says the exact same thing. It's based in R2 because it can only take in two entries, two rows. And when you multiply x by y, it has to be greater than or equal to 0. The first question is if U, so it's a vector because it's bolded, or you can think of a vector as a point, so if to any of these points, and C is any scalar, aka C is just any number, is CU in W? Why? Well, the key thing is to note that it says that x and y together can be equal to 0. So this here is included as well, so this right here. And so if you have any vector u like this, and you scale it, let's say by 2, then it will be double that. Then let's say that you scale this one by -15. So -15 is any scalar. You can do any scalar. What does that mean? It means it's gonna go all the way over here. And so the idea is if you have any vector in these quadrants, and you scale it by any number, by any scalar, the resulting vector is still going to be in W, in this pink area. So the worst that this scalar can do with any vector here is just scale it so that it reaches across. In other words, scale it to be a long line. Multiplying a vector that's in here or one that's in here by any scalar is not going to get you to over here or over here. So the idea is that yes, the resulting vector will always be in W. So here's what I just said. And then for B, we're told to find specific vectors U and V in W such that U plus V is not in W. So my strategy is to pick a vector that's outside of W, so not in the pink area. So maybe something like this where it would be 1, -1. Then for my vector U, I'm just going to pick a vector inside W, so inside the pink space. So let's say I pick something like over here where it's 1 and 2. This is vector U. Then to find my other vector, I just ask myself, how can I get from here to here? Well, I add nothing. How can I get from here to here? Well, I would subtract -3 because -3 plus 2, that gives you -1. And then you check, okay, is 0, -3 a vector in the pink space? Well, 0 is right here, and then down -3, that would be the vector. And that's still part of this space because it says that we can include 0. So we found two vectors whose sum, whose resulting vector, this one, is outside of W, outside of the pink space. And sometimes it might not work in the first round. You always have to check that these two are actually inside your first and third quadrants. And that's it for this video. I'll see you in the next.